This question says complete the table below. Be sure each of your entries has the correct number of significant figures, and we can assume that it's at 25 degrees C. So the first thing we need is the formula of the conjugate base of the acid HBrO. So when this acts as an acid, it loses a proton. When it loses a proton, what's left, the conjugate base, is BrO minus. Now we need to find the Kb of this. Well, to do that, we need to remember that Ka times Kb equals Kw. And Kw is 1 times 10 to the minus 14. So we can rearrange this equation, which is Kb equals Kw divided by Ka. Plugging in, Kw is 1 times 10 to the minus 14. And again, I consider this as significant figureless, divided by 2.3 times 10 to the minus 9. When you do the math, you find that it's 4.3 times 10 to the minus 6. Since this has two sig figs, this should also have two sig figs, and we kind of ignore the sig figs on this one, and we put in 4.3 times 10 to the minus 6. This case is the opposite. We're given the base, and we want to find the conjugate acid. So if this acts as a base, it gains a proton. When it gains a proton, you get HONH3, so it goes from 2 to 3, and it also gains a plus charge. The formula to find it is the same as this, except you put Kb on the bottom. So the Ka equals Kw divided by Kb. In this case, it's 1 times 10 to the minus 14 divided by 1.1 times 10 to the minus 8, the Kb that's given. And when you do that, you find that it's 9.2 times 10 to the minus 7. So this is 9.2 times 10 to the minus 7. Finally, for NH3, it's going to act as a base and gain a proton. So it goes from NH3 to NH4. It goes from neutral to plus. So this is the conjugate acid of that. The formula is the same. Ka equals Kw divided by Kb. 1 times 10 to the minus 14 divided by the Kb that's given, 1.8 times 10 to the minus 5. And when you do all that, you find that the Ka is 5.6 times 10 to the minus 10. So we can plug that in for our answer. And that's how you find both the conjugate acid or the conjugate base and the Kb from the Ka or the Ka from the Kb.